Now that you have designed Azure policy and governance guardrails to enforce standards and compliance, you are ready to control the most powerful part of any cloud platform. Who can do what? Governance defines what should be true in your environment, but role-based access control determines who can change what becomes true. If governance is the rules of the road, role-based access control is who holds the steering wheel. A mature Azure environment cannot rely on good intentions. It must rely on designed access boundaries that protect the business while still enabling teams to deliver. With that context, you should treat least privilege as a leadership requirement, not a security slogan. Least privilege means people and systems have only the access they need, for only as long as they need it, at only the scope they need. Leaders care because excessive access is one of the fastest paths from a small mistake to a major incident. Architects care because excessive access destroys accountability and creates operational chaos, where everyone can change anything and nobody can explain what happened. Least privilege protects reliability, compliance, and trust as much as it protects security. With least privilege defined, you now frame role-based access control as an organizational design system rather than a list of roles. Role-based access control defines how responsibilities are distributed across platform teams, security teams, application teams, and service owners. It is how you encode your operating model into the platform. When it is designed well, teams move faster because access pathways are clear and repeatable. When it is designed poorly, access becomes negotiated in emergencies, and that is where permanent over-permissioning begins. With role-based access control positioned correctly, you now anchor the design around 3 questions that make it defensible. Who should be able to perform a task, meaning which job function or team owns it? What should they be able to do, meaning which actions are necessary and which are not? Where should they be able to do it, meaning the scope boundaries that keep impact contained. When you design role-based access control through these questions, your model becomes understandable, auditable, and aligned to accountability. With the design question set, you now explain scope as the core lever of least privilege. Scope determines blast radius. When you assign access at a high scope, you increase convenience but also increase risk. When you assign access at a lower scope, you reduce risk but must manage access thoughtfully. The leadership lesson is that scope is not a technical preference. It is a risk boundary decision. As an architect, you design scopes so teams can operate effectively while incidents and mistakes remain containable. With scope understood, you now explain role choice as a balance between standardization and precision. Built-in roles provide consistency and are easier to govern because they are well-known and widely used. Custom roles provide precision when built-in roles are too broad or do not match your operating model. The leadership concern is governance overhead, because too many custom roles can create confusion and maintenance burden. The architectural goal is to start with built-in roles where possible and introduce custom roles only where there is a clear and recurring need that cannot be safely met otherwise. With role selection clear, you now introduce separation of duties as a core governance principle. Separation of duties means no single person should be able to both approve and implement high-impact changes without oversight. For example, the person who manages security policies should not be the only person who can disable monitoring, and the person who deploys infrastructure should not be the only person who can grant themselves more access. Leaders care because separation of duties reduces fraud and insider risk. Architects care because it improves control integrity and supports audit expectations. With separation of duties established, you now design access for the platform team because this is where many environments drift into. Platform administrators can do everything. Your platform team needs meaningful permissions to operate shared services, networking, governance, and observability foundations. At the same time, you want to avoid giving them unrestricted access to every workload resource unless it is required for platform operations. The leadership outcome is accountability. Workload teams remain owners of their applications, while the platform team remains owner of the platform layer. The architectural outcome is fewer unnecessary privileges and cleaner incident investigation because responsibilities are clearer. With platform access clarified, you now define access for application teams in a way that enables delivery without expanding risk. Application teams typically need permissions to deploy and operate their workloads within their own scopes, such as their subscriptions or resource groups. They should not require broad permissions across unrelated environments. Your design also distinguishes between development access and production change access, because production changes require stronger governance and higher confidence. Leaders care because controlled boundaries reduce the chance of production incidents. Architects care because standardized access boundaries reduce friction and speed up onboarding for new teams. With application access defined, you now design access for security teams, so oversight is possible without turning security into an operational bottleneck. Security teams need visibility across the estate, including access to logs, policy compliance posture, and security findings. They may also need controlled ability to enforce or validate guardrails. However, you avoid granting security teams broad permissions to modify application resources unless there is a defined operational need and governance model. Leaders care because security oversight must be effective. Architects care because separation between oversight and operations reduces risk of accidental changes and preserves clear accountability. With team access patterns established, you now address privilege access because privilege roles are where least privilege is most often violated. Privilege access should be time-bound and approval-aware where appropriate, so administrators do not hold permanent standing access. This reduces the chance that stolen credentials lead to catastrophic impact. It also improves auditability because privilege actions become deliberate and traceable. Leaders value this because it reduces high severity risk. Architects value it because it creates a disciplined operating model that can scale without becoming everyone is an owner. With privilege access controlled, you now address permission creep because access naturally expands over time unless you design for lifecycle management. People change roles, contractors leave, project teams dissolve, and temporary access becomes permanent if nobody reviews it. Your role-based access control design must include regular access reviews, ownership of reviews, and clear processes for removal. Leaders care because permission creep increases breach risk and audit failures. Architects care because permission creep erodes accountability and makes incident response slower and more political. With lifecycle discipline in place, you now cover emergency access because every enterprise needs a safe way to recover from identity issues, outages, and misconfigurations. Emergency access, often called break glass access, must be tightly controlled, monitored, and used only under defined circumstances. The danger is that emergency access becomes a quiet backdoor if it is not governed. Leaders care because emergency pathways must exist for resilience but must not become hidden risk. Architects care because well-designed emergency access prevents operational lockout while preserving security integrity. With access patterns clear, you now connect role-based access control back to Azure policy and governance because these controls must reinforce each other. Azure policy enforces environment guardrails, and role-based access control ensures only authorized people can change or bypass those guardrails. This integration is what makes governance durable. Leaders value it because it creates assurance that standards are not only documented but protected. Architects value it because it reduces the number of exceptions and emergency fixes caused by uncontrolled access. With integration understood, you now ground the value with a realistic scenario. Imagine a developer has broad subscription level access in production just to unblock a release. Under pressure, they change a network setting or disable a monitoring rule, unintentionally exposing a service or hiding alerts. The incident escalates, and nobody can quickly explain what changed because too many people had too much access. In a least privilege design, the developer has scoped access only where needed. Production changes require controlled pathways, and privilege actions are time-bound and traceable. The outcome is fewer incidents, faster investigation, and higher leadership confidence. With the scenario clear, you now focus on sustainability because role-based access control is not set and forget. You design reusable access patterns for common roles, document them clearly, and make onboarding predictable. You establish review cadences so access remains current as teams change. You also keep the model simple enough that people can follow it without constant interpretation. Leaders care because sustainable access control reduces long-term risk and operational cost. Architects care because a sustainable model prevents drift and supports consistent architecture outcomes across many teams. Let's now discuss the key takeaways from what you learned so far, so you can design least privilege role-based access control that leaders trust and architects can defend. Least privilege is a leadership requirement because excessive permissions increase the probability and impact of incidents and destroy accountability. Role-based access control is an organizational design system that encodes your operating model into Azure. Your access model must answer who can perform tasks, what they can do, and where they can do it, and scope is your primary risk boundary. Built-in roles support standardization, custom roles support precision, and you should balance both to avoid complexity. Separation of duties prevents any single person from controlling high-impact outcomes without oversight. Platform, application, and security teams need different access patterns aligned to responsibilities, and privilege access should be time-bound and auditable to reduce standing risk. Access reviews prevent permission creep, emergency access must be governed to avoid backdoors, and role-based access control must integrate with Azure policy to keep guardrails durable. If you want your Azure environment to stay secure and governable as teams scale, subscribe so you can continue through the rest of this playlist and complete the enterprise architecture journey. Like this video so more leaders and architects learn how to design least privilege access models. Comment with your biggest role-based access control challenge such as scope design, privilege access governance, or access reviews, and share this with your team so you can align on one clear access model that enables delivery while protecting the business.